All right, guys, I'm trying something new. I had to start recording before I open Notability, or Notability closes automatically on me. But I got it open, so I'm pretty excited. Anyway, let's learn this lesson. Okay, today we're talking about applications of integration. And you're given, you're going to be given rate equations. That's the word I was looking for. That says equations. All right, if you integrate rate, you're going to get, that's dt, you get the units, okay? Which doesn't make sense. So what I'm trying to say is that, this is feet. No, let's not do feet. We're going to do cars per hour. And this is hours. I draw the graph. And I find the area of my rectangle. Cars per hour times hours leaves you just cars. So it tells you how many cars were there. All right, so the questions today are asking how much, averages, okay? So here's the problem. Water's leaking out of your pipes at a rate of 5 over x plus 1 in liters per hour. How many liters have leaked out in the past 6 hours? So what I'm going to do is integrate. How did I get so fat? There we go. From 0 to 6, 5 over x plus 1 dx. Well, I have to use substitution. I hope you recognize that. U is equal to x plus 1. And du is equal to dx. And this is a leading coefficient, so I can put that out front. And I have 1 over u du. And I hope you remember that that's the natural log of u and I have to change, I already made a mistake. These bounds have to change in terms of u. So you put 6 in there, plus 1 is 7, and 0 plus 1 is 1. So I'm going to integrate from 1 to 7. I have 5 times the natural log of 7 minus the natural log of 1. The natural log of 1 is 0, and I put that in my calculator. The natural log times 5 times the natural log of 7 gives me 9.73 liters. Now remember to use your units. On the AP exam, the free response questions are only worth 9 points, and you lose 1 if you forget your units, and that's just silly. You lose your points for not knowing your math, not because you forgot the unit. Okay? All right. On a typical day, the city consumes water at a rate of, in gallons per hour. What is the number of hours past midnight? Where T is the number of hours. And it says, what's the daily consumption? Well, a day has 24 hours. And another thing on the AP exam, instead of putting in the whole equation, you can write R of T because it's defined right here. Okay? And then you do your integration, so you get 100T plus 72T squared over 2 is 46T squared minus T cubed from 0 to 24. And you grab your calculator, and you get 9,312 gallons. Okay, how much water is consumed between 6 p.m. and midnight? Well, it's 6 hours, but you don't want to integrate from 0 to 6 because you're not starting at 0. The rate that water is being consumed changes during the day according to that equation. So I have to integrate from 18 to 24. Okay? And you put it in your calculator, and you got your 100T plus 46T squared minus T cubed from 18 to 24, and it tells you did 1,680 gallons. Okay, and then it says, what's the average rate of consumption per hour each day? Well, remember, average is 1 over b minus a out front. Your integration from 0 to 24 of RT dt. And since we already know it's 9,312 divided by 24 gives me 388 gallons per hour. I'm going to add a question on here, part D. And I want to know, is the rate increasing or decreasing at 8 a.m.? Increasing or decreasing at 8 a.m.? Well, you need A of t, which is the derivative of the equation, so you get 72 minus 6t. So A of 8 equals 24. V of 8 equals 484. Since they're both positive, it's increasing. Okay? Last question. They give you a learning curve for putting bicycles together. And what it means is that it takes a bicycle mechanic L of n hours to assemble the nth bicycle. You want to know how long it takes the mechanic to produce 24 bicycles. So he's new, he's never put a bicycle together before, he's never opened the box, he's clueless. Okay, so I've got to integrate this. That is -1/5. And I put that in my calculator to save ourselves some time, and I got 190.66 hours. That's a long time. You work a 40-hour work week, right? So that took them a month to put together 24 bicycles. All right, how long does it take them to produce the next batch of 12? Well, you're not going to integrate 0 to 12 because it's not the first 12. Hopefully he's getting better and faster. All right, that's a graph that's coming down, so you're going to integrate from 18 to 24. And I got 73.05 hours. So it's getting faster. Okay, right? If you doubled, that'd be 140. So he got better. All right. Now it says, what's the average time to produce the bicycle during the first 24-hour produced, for the first 24 bicycles produced, and what about the next 12 hours? So you take 190.66 and divide by 24, and you get 7.94 hours. And you have 73.05 divided by 12 is 6.08 hours. Okay, so really you had 1 over 24 times the integration 0 to 24 of ln dn, and this was 1 over 12 of 18 to 24. Even though this is 18 to 24, remember this is b minus a, so b minus a gives you 12. Okay, so that's all there is to the lesson. I think I did an example of everything. A lot of integration, and you get to use calculators again. Thanks, bye-bye.